Imagine a world without gravity. Would we float aimlessly in the sky, or would something far more drastic occur? Gravity, an omnipresent force, is a key player in our day-to-day lives, even if we don't always recognize it. It's as natural to us as breathing. It's there when we get out of bed in the morning, holding us firmly to the ground. It's there when we pour our morning coffee, guiding the liquid into the cup. It's there when we take a step, jump, or run, shaping our every movement. Yet, despite being so integral to our lives, we rarely stop to ponder its importance. It's easy to forget that gravity is the reason we're not floating off into space, the reason why our world is the shape it is, or why we experience time in the way we do. Gravity is not just a force that keeps us grounded, it's a cosmic glue that holds our universe together. It dictates the orbits of planets around their stars, the formation of galaxies, and even the path light takes when it travels. It's a fundamental part of the cosmic dance that shapes our universe. But what if, one day, gravity simply stopped existing? What if this invisible, omnipresent force just disappeared? Would we float aimlessly in the sky, or would something far more drastic occur? The reality is, gravity is more than just the force that stops us from floating away. It's the architect of our universe, the sculptor of our planet, and the choreographer of our daily lives. It's woven into the very fabric of our existence, influencing everything from the smallest particle to the grandest galaxy. Without gravity, life as we know it would be impossible. Our world, our universe, would be unrecognizable. It's a thought that's as mind-boggling as it is terrifying. So how do we comprehend a life without this invisible force? Gravity as we know it is not just a word from our science textbooks. It's the invisible glue that binds our universe together. So, what exactly is gravity? Simply put, it's a force that attracts two objects towards each other. But don't let the simplicity of that statement fool you. The science behind gravity is far from simple. In the late 17th century, Sir Isaac Newton formulated the law of universal gravitation. According to this law, every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law was a game changer. It allowed us to predict the motion of celestial bodies with astonishing precision. Fast forward to the early 20th century, a man by the name of Albert Einstein proposed a radical new understanding of gravity. His theory of general relativity suggested that gravity is not a force per se, but rather a consequence of the curvature of space-time caused by mass and energy. This theory, as mind-boggling as it might sound, has been proven correct time and again. So, in essence, gravity is the force that pulls apples down from trees and keeps our feet firmly on the ground. It's the reason the Earth orbits the Sun, and why galaxies cluster together in the vast expanse of the cosmos. Gravity is the unseen puppeteer, subtly shaping and directing the dance of the universe. It's the reason we experience weight and why skyscrapers stand tall. It's why our planet is round, and why it doesn't wander off into the cold, dark void of space. But what if there was no gravity? What if this invisible string that holds everything together suddenly disappeared? Well, the consequences would be catastrophic, to say the least, but more on that later. Without gravity, the world as we know it would cease to exist. Now let's delve into the realm of the unimaginable, a world devoid of gravity. Picture this: a world where you float instead of walk, where buildings, trees, and even oceans hover in mid-air. Sounds fun, doesn't it? But let's take a closer look at this gravity-free scenario. First up, our bodies. We're built for a world with gravity. Our bones and muscles develop strength from resisting gravity's pull. Without it, our muscles would weaken and our bones would lose density. Over time, we'd become fragile, like astronauts who've spent extended periods in the weightlessness of space. Next, our atmosphere. Gravity holds our atmosphere in place, the very blanket of air we need to breathe. Without gravity, this life-sustaining envelope of gases would drift off into space, leaving Earth barren and inhospitable, a silent, airless wasteland. Now consider our oceans. Imagine the entirety of Earth's water supply, from the deepest ocean trench to the smallest mountain stream, suddenly released from gravity's grip. We'd witness an unprecedented global flood as water ascended into the sky, only to freeze in the vacuum of space. Lastly, let's think about Earth's rotation. Our planet spins on its axis, creating a centrifugal force that's balanced by gravity. Strip away gravity, and this balance is lost. The Earth would start to spin faster and faster, its shape distorting into an oblate spheroid. Days would shorten dramatically, and the extreme centrifugal force could rip our planet apart. So while a world without gravity might sound like a thrilling science fiction scenario, the reality would be far less entertaining. Our bodies would deteriorate, our atmosphere would vanish, our oceans would ascend to the heavens, and Earth itself could self-destruct. Clearly, gravity's absence would have catastrophic implications. We rely on gravity for so much more than just keeping our feet on the ground. It's the invisible but indispensable force that shapes our world and our lives. Gravity isn't just crucial for life on Earth, it's the fundamental force shaping the universe. In the vast expanse of space, gravity is the unseen puppet master, the invisible hand that molds the cosmos into its magnificent forms. It's the celestial choreographer, dictating the dance of planets, stars, and galaxies. Consider our solar system. The Sun, a massive sphere of burning gas, exerts a gravitational pull on the planets, keeping them in their orbits. Without gravity, planets like Earth would simply drift away into the inky void of space. And it's not just about keeping planets in check. Gravity is instrumental in their formation too. Picture a cloud of cosmic dust and gas. Over eons, gravity pulls this matter together, compacting it into a spinning disk. In the heart of this disk, a star is born. Around it, lumps of matter collide and merge, forming planets. This is the birth of a solar system, all orchestrated by the unyielding force of gravity. But gravity's influence extends beyond our solar system. Across the universe, gravity weaves together galaxies, those vast islands of stars, gas, and dark matter. These cosmic structures, with their spiral arms and elliptical shapes, owe their existence to gravity's relentless pull. And then there are black holes, the ultimate testament to gravity's might. When a massive star collapses under its own weight, it forms a black hole, an object with a gravitational pull so strong that nothing, not even light, can escape it. In a universe without gravity, there would be no planets, no stars, no galaxies, and no black holes. There would be no structure, no order, just an endless, amorphous cloud of cosmic dust and gas. Gravity, then, is not just a force, it's a cosmic sculptor, shaping the universe as we know it. It's the reason we have the night sky's glittering array of stars, the reason we have the diverse worlds of our solar system. Without gravity, the cosmos would be a chaotic and unstructured abyss. We've embarked on a journey from our everyday lives to the edges of the universe, all under the influence of gravity. Quite the adventure, wouldn't you agree? We started by exploring the gravity of the situation, to truly appreciate the force that keeps our feet firmly planted on the ground. It's the same force that keeps our planet in its orbit around the sun, and ensures that our coffee stays in the cup instead of floating around the room. We then dived into defining gravity, a force of attraction that pulls two objects toward each other. The greater the mass of the objects, the stronger the force of gravity. Yet it's a force so weak that we can overcome it with a simple jump, but so strong it keeps billions of galaxies in their places. The intriguing part was imagining life without gravity. We'd be floating around with no up or down, left or right. Our bodies would change, becoming taller and thinner. The oceans and atmosphere would drift off into space, and Earth would lose its spherical shape. We also ventured beyond Earth to understand gravity's role in the universe. It's the invisible puppeteer, choreographing the dance of celestial bodies, from the spiraling galaxies to the birth and death of stars. In this short span, we've journeyed from the mundane to the extraordinary, appreciating gravity's silent yet profound influence on our lives and the cosmos. It's easy to take gravity for granted when it's always been a constant in our lives. Yet without it, the universe would be a chaotic, unrecognizable place. Gravity shapes our world, our bodies, and even our understanding of the universe. It's not just a force, but a fundamental principle that governs the cosmos. Without gravity, life as we know it would be impossible. So, the next time you feel weighed down, remember, gravity's got your back.